And now we're going to talk about the Doppler effect. And so we have the Doppler effect. And that's going to be a frequency shift Okay, it's going to be a frequency shift due to the relative velocity between the source of the sound and the listener. Okay, and you can watch, I put two supplemental videos, one of a fire engine going past a camera, and another one a person honking their horn and going past a camera. And so you can watch both of those. And so some errors. Okay, some errors and thoughts about the Doppler effect. Okay, one. Distance matters. No. Velocity matters. It doesn't matter how far away the ambulance is. It does not matter how far away the ambulance is. What matters is how fast is the ambulance coming towards you. So if you're standing on the side of the road and you're watching this ambulance come towards you, as long as it's coming towards you at a constant velocity, you're going to hear that Doppler shift. 2. Louder, softer. No. Okay, a lot of people think that Doppler effect is that, oh, well, as something is coming towards you, it gets louder, and as it goes away from you, it gets softer. No, that has to do with this. That as it comes towards you, it gets louder, and it goes away from you, it gets softer. That has to do with this equation. It does not have to do with the Doppler effect. What the Doppler effect has to do with is pitch or frequency. As the ambulance is coming towards you, you hear the siren has a higher pitch. As the ambulance is going away from you, you hear a lower pitch. So there's a change in the frequency depending on the velocity. So what matters? What matters is the frequency shift and the relative velocity. Frequency shift is related to relative velocity. Okay, so now if we have a couple of diagrams here, if we go to this sort of thing, we know that we have spherical sound waves. And so now we're going to have a stationary sound source. So the centers So what I do is I have a little speaker here, and the speaker puts out a sound, and then it puts out, and it's putting out a vibration, right? And so as it's putting out a vibration, it's sending out spheres. And as those spheres go out, every single one of the spheres is going to be, every single one of those spheres is going to have the sound source as the center. And so then these distances, that's going to be x, 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 that's going to be x. And all of these distances are going to be all the same. So all distances are the same between those spheres. And that's going to be x, and that's going to be x, and that's going to be x, etc., etc., etc. Okay, now we're going to have moving sound source. The center of the sphere So with a moving source, the center of the sphere is going to be where the source was at an earlier time. Okay, so I've got a source that's going, it's there, but then later it's there, and then later it's there, and then later it's there, and later it's there. Now, if I have, I should have made that a little bit smaller, it's going to be hard to see, but so at that point in time, this is putting out a sphere that's, let's make it, so that's putting out a sphere like this. Well, at an earlier time, it put out a sphere like that, and I'm not making exact spheres, and at an even earlier time, it put out a sphere like that, and at an even earlier time, so this one goes with this one goes with this one goes with this, and so then at an earlier time, again, it's going to be like that, and it's going to be off the page. And so out front, we're going to have these distances are going to be, we'll call them y, and then sort of down here, these are going to be like x and x, and then back here, these distances are going to be like z and z. So the object is moving this way. And so to wrap this up really quickly, because I don't want to get into another video, when it's coming towards you, the wave fronts are going to hit you faster and faster and faster, so you're going to hear a higher frequency. When it's moving away from you, the wave fronts are going to hit you less frequently, and when it's passing right by you, not moving towards you or away from you, you're going to hear the same frequency you would hear if it was just stationary.